Hey there, Patrick from Ollie here, and in this video we're going to get into the main menu of earth.nullschool.net and some of the things that you can do with this really powerful website. So when you open the website, in the lower left corner you'll see the word Earth. If you tap or click on it, you'll get this whole menu of options. And we're going to do a basic overview of everything you see here, but we're actually going to do a series of videos of all the different options that we have in here because there's a lot. So up top you'll see the date and time. And today's date is April 28th, 2020. And we're actually looking at a map from 1800 UTC, or if you tap on local there, 11 o'clock in the morning local time. So the first thing I'm going to do is actually change that date and time because there's something really interesting I want to show you. If you click on the calendar in the fifth row, you can actually choose the date that you want to look at the weather for going back to 2013. So there's a ton of information in here. But we're going to go back to 2018, January 4th, and we'll hit apply, and you'll see a storm right off the coast of the East Coast here. So I'm going to tap on the menu again, and I'm just going to zoom in on that spot right there to show you some really interesting things. So if you look at the top line here, we've got the date, which is January 3rd, 2018, and about 2200 local time. Or if you tap on UTC, that's about 6 a.m. UTC the next day. So that's January 4th, 2018. The current layer we're looking at is the wind at the surface, and the scale reflects the speed of the wind in this case. So if you look at this point right here, for example, the wind is only blowing about 5 kilometers per hour, and it's blue on the color scale. If we pick a spot like right down here, the wind is blowing at about 100 kilometers per hour, and you can see it's kind of into the orange-red area. And again, if you're not familiar with kilometers per hour, you can tap on the units and you can see it in meters per second, knots, or 62 miles per hour. So that's actually getting close to a tropical storm in the middle of January, which is pretty wild. But we're going to pop back to kilometers per hour. And the next thing I want to show you is actually some of the overlays. So within the air mode, you've got a bunch of different overlays below. So you've got wind, temperature, relative humidity, etc. And if you're curious what these different abbreviations stand for, you can actually just hover your mouse over each one and it will tell you what you're looking at. So we're going to get into each one of these in a later video. But right now I want to go to temperature. And this is a really interesting phenomenon that we're looking at right here. So in order to best see this, I'm going to turn off the animation. So I'm going to hit the yellow play button here. And right now we're just looking at the air temperature at the surface. And you see in that point right offshore, the air temperature is about 14.7 degrees Celsius or 58.5 degrees Fahrenheit. Remember, this is in January, which is pretty wild. If we go right over to the land next door, it's actually only about 24.4 degrees Fahrenheit or negative 4.2 degrees Celsius. So you can see how much of an influence the warm ocean water has on the air temperature right above it. So even in the dead of winter, you can have really warm air right offshore. You'll also notice that the color bar has changed here. So if I tap on wind again, you'll see the color spectrum changes, and you can also see those changes in the colors of the wind. Can you paint with all the colors of the wind? But going back to temperature, you'll see that the rainbow has shifted a bit to the left to account for the bigger range of temperatures. You'll also notice that now that we're in the temperature layer, in our information box up top, we have latitude and longitude and the direction and the speed of wind, but we also have the temperature below it. So as we explore these different overlays, we'll be able to see the information for that point in each one. So I'm going to go back to wind speed over here, so the wind overlay, and I'm going to turn the animation back on. And then I want to zoom out a little bit. So what we're going to do is on the level up, you see height, and that is the height of the model. So right now we're looking at surface wind conditions, but we can actually look at wind conditions even higher up in the atmosphere. So you'll notice in height that the scale here is not in meters or kilometers or feet or miles. It's actually in HPA, which is hectopascals. And that's because when a computer model is calculating different phenomena at different layers of the atmosphere, they think of it not in height, but in air pressure. So think of it as different bands where the air pressure is lower and lower. So right down by the surface, air pressure is super high. It's about 1,000 HPA. But as you go higher up in the atmosphere, air pressure drops. So that's why you'll see the numbers go down as you go higher up in the atmosphere. So if we look at 700 HPA, for example, you'll notice that the wind is blowing a lot faster. And I'm actually going to zoom out a little bit so you can see that better. And way up there, wind can be blowing at 147 kilometers per hour. Will actually pop up to 250 hectopascals. And you're up in the territory now where we see the jet stream. This is one of the really strong wind patterns that shapes a lot of the local weather. It actually pushes systems around the planet. That's why in the northern hemisphere, a lot of our weather comes from the west because it's being driven by things like the jet stream here. And you'll notice that, you know, up here the wind is blowing at 297 kilometers per hour, and for all of you Americans, that's 184 miles per hour. Incidentally, that's why it takes a lot longer to fly from Europe to North America than it does to go from North America to Europe. If you're flying from London to Boston, you're facing a headwind that can be blowing 200, 300 kilometers per hour, whereas if you're going from Boston to London, that's a tailwind that'll push you along. And actually a few months ago, there was a plane that was technically going faster than the speed of sound because it was flying with this super strong tailwind, which was pushing it along, and it arrived at its destination like an hour and a half ahead of time. It was crazy. Anyways, so these are really strong wind patterns up in the upper atmosphere, and you can see that as you go higher and higher up. And if we go even higher up to about 10 hectopascals and go up to the top of the planet here, you'll see this really neat loop. Let me close the menu real quick. And this loop is what is called the Polar Vortex. So this forms in the wintertime in the northern hemisphere, where you usually have this really tight band of wind spinning around the northern hemisphere. But sometimes it'll get a little bit wibbly wobbly and it'll actually slip down and blast us with some freezing air from the Arctic. So this is a pretty healthy polar vortex right now. So that's the basics of the main menu, and in the next video we're going to get into the different overlays within each mode. So we're going to start with air, and then we'll get into the ocean, the chemistry, particulates, etc. Thanks for watching, and make sure you check out the other videos in this series.